So, today we'll be driving a 12-meter pile. The soil on this site has very low load-bearing capacity. There's about 2 meters of loose debris on top, followed by mangrove swamp soil, as we're close to the ocean. Beneath that, there's something more solid. We'll be driving two 6-meter composite piles, totaling 12 meters. Let's see how it goes. Now we've passed through the solid layer, and the pile is sinking into the swamp. Watch how quickly it goes down. This is what happens when you hit a weak soil layer. We've driven the first 6-meter pile. This pile has a metal cap, and now we're adding another 6-meter pile, with a metal plate at the bottom. We'll align them, weld the joint, apply waterproofing, and continue driving. We've driven a 12-meter pile, but its load-bearing capacity is only 1 ton. Now we're adding another cap, placing another 6 meters, and continuing until the pile reaches a load-bearing capacity of at least 10 tons. This demonstrates that in areas like this, and there are plenty of such sites in Indonesia, it's impossible to build without driven piles. There is an option to use board piles, but that costs as much as a jet wing, and takes about a week. Here, we can drive a ready-made concrete pile in just 40 minutes. Now we have 18 meters of pile in the ground, with a load-bearing capacity of around 7 tons. However, we need to achieve at least 10 tons. So, we've added another 6 meters and continue driving. I want to say that we've broken the record held in St. Petersburg. The pile is now 24 meters deep, but the load-bearing capacity hasn't improved. We're still going through some kind of liquid soil. We'll add yet another pile and keep driving. For BIMx Basis, nothing is impossible. We will eventually reach solid ground and achieve a load-bearing capacity of 10 tons. We continue driving the pile, and we can see that the impact energy is increasing, while the penetration depth per strike decreases. This means the pile's load-bearing capacity is steadily increasing. By the time we're finished, we expect a capacity of 10 to 15 tons. Most importantly, at the end, we'll know the exact load-bearing capacity of this pile. So, we've successfully driven a 27-meter pile. The first 1.5 meters were tough because the top layer here is not soil, but loose fill and debris. Then the pile passed through a mangrove swamp, and only the last 3 meters reached a solid load-bearing layer. Dynamic testing confirmed that this pile can bear 13.5 tons. This is more than sufficient to support the walls of our hangar. And the best part? Today, we proved that we can construct any building on any type of soil without choosing expensive board piles. This is a 200 by 200 pile, but we can drive piles of any size and length to meet the project's needs.